Let's now talk about the final application using a stack. And I would say this one might be more challenging than the earlier two problems. Remember we talked about how to reverse an array using a stack and also how we match the delimiters using a stack. But this one here actually requires deeper understanding about how to use a stack, but we'll see. So the problem is, given a postfix expression, how do we calculate its value? Of course, we want to define what a postfix expression is as opposed to infix. The infix expression is really what you are used to. But let's now compare the two expressions. They're equivalent to each other, but just syntactically they're different. Right, so I got different examples over here, but here is the principle. When you talk about infix notation, operator will be in between the operands. So that's why it's called infix. But now for postfix notation, the operator will follow the operands. All right, so here we actually got different example over here. You can go over them, but I'll also go over some different examples in detail together with you first before we try to solve the problem. Another insight about these two notation is, in the case of the infix notation, you will have to put parentheses whenever necessary to really force the order of evaluation. For example, let's say in this case over here, I want to say that 3 minus 4 should be done before multiply by 5. However, in the case of the postfix notation, interestingly, you really don't need any parentheses, because the way you write out the expression is going to embed the order of evaluation. So I'm going to let you study about the different correspondences over here listed on the table, but let me give you two examples very quickly so we can get an intuition, and then I will give you some idea and also some example run about the algorithm. But how to really implement it in Java code and also how to test it to be correct, it will be up to you. I'll rely on you to actually go beyond this lecture over here to do it. Right, so now here I'm showing different expression over here. I'll go over maybe the first two, okay? These two and these two over here. So this is the postfix notation and this is the infix notation. You can see in the case of the infix notation, I put a parenthesis just to show the explicit order of evaluation. In this case, we want to multiply 4 and 5 first before we do the subtraction. In this case, we want to subtract 4 from 3 before we multiply by 5, right? So let's see how these two different infix notations will be translated into the postfix notation without any parentheses. Okay, so this is equivalent to this, but how do we understand it? The best way intuitively is really to look for operators which comes after two numbers. Look for instances like that, and then what follows I'll show you. Okay, let's say for this one here, you can see for this part here, I got multiply and then 4 and 5, right? I got two operands for multiply. So this really corresponds to 4 times 5 over here. And then you can see we got another minus over here. So whenever you got an operator, that means you should really get it's a right operand, which is this case, and also left operand, right? So in this case, if you just try to box it again, let me try to do it over here. So this one over here is really about the minus is actually over here, and then you got the left operand and also right operand. So this will be left operand, this will be the right operand. So this will be 3 minus 4 times 5, right? So that's how I work out exactly exactly what the corresponding infix notation is for this postfix syntax over here. Let's see another example. Following the same principle, let's look for the operator which comes after two numerical values. So you can see this is the first one. Okay, let me use green. Right, you can see this is the first one over here. So this will correspond to 3 minus 4, right, in parentheses over here. So that means we want to do it alone. And then you can see the next one is we got multiply, and this will be the right operand, and this entire thing will be the left operand, right? If you try to box it again, so let me just try to do that. So this part over here, so this will correspond to the multiply, and then you can see 5 is the right operand over here, and 3 times 4 is the left operand over here. So that's exactly how I work out the corresponding infix notation, right? So hopefully you got some kind of intuition, and you can also try to apply the same intuition to see why these two expressions are actually not valid, because if you try to turn them into the corresponding infix notation, you will see that we are either missing some operand over here, we're missing the right operand in this case for the plus, and also we got some additional operand with no associated operator, right? So these are two erroneous cases. That's something your algorithm in Java will have to handle, but I'll give you some hints as well. All right, let me now go back over here. And so I got some sketch of solution. I will let you read the slides. I think the solution is rather, well, I mean the sketch is rather clear. I'll let you read it, but I'll just run over some example together with you, okay? Let's see input number 1. So input number 1 over here. And the way we scan through the input is the same as how we did it for the matching delimiters example. We're going to scan through the input string from left to right. So for example, in this case, the first character will be 3, second character will be 4, third character will be 5, and then star, and then minus, and etc. for other input value as well. And we're going to use a stack over here, and then I'll tell you the principle in just a moment. Okay? Of course, I'm being consistent with what I lay out over here in the sketch of solution, but you can read it by yourself. Okay. So the idea would be, whenever you see any numerical value like a 3, 4, 5, you simply push onto the stack, right? Unconditionally. Whenever you see any operator, like for example, multiply over here, what you should do is you should really try to pop off the stack for twice. The first time you pop off the stack, that would be the right operand. And the second time you pop off the stack, it should be the left operand. So the right operand and the left operand, not the left and the right, right? It should be the reverse order. Think about it's more like a last in, first out, right? The right operand followed by the left operand. So that'll be the principle, okay? Let's now take a look. So the first input character will be 3, and then push, and then followed by 4, push, followed by 5, push. So far we got 3 numerical values in the stack. And the next one will be a operator. So that means we actually want to do some multiplication. And we're going to need its right operand followed by its right operand. So right operand is going to be the first pop. The left operand is going to be the second pop, which will be 4, right? And you're going to evaluate this right away, which will be 20. And you want to push this back to the stack. That's a very important step to always keep in mind. And let's now go to the next input character. What's the next one? After multiplication, the next one will be subtraction. So that means we got some subtraction to do, and we need the right operand followed by the left operand. The right operand is going to be the top of the stack, the first pop, which will be 20. And the left operand will be the second pop, which will be 3. Right? So that'll be 3 over here. So that'll be minus 17. And make sure you actually push this back to the stack. As before, in that case, this will be the final answer to really return for your algorithm. Right? You can see this result over here will simply match this result here. You can just verify that by yourself. Right? So the first example. Let's look at the second one. Maybe after the first two, you really get an essence about how you should really handle the normal cases. The second input over here will be handled in a very similar way. So we're going to see the input character 3, followed by 4, followed by minus, followed by 5, followed by star. Okay. And for input number 2, let's now create a new stack. Right, let me put it exactly over here, right beside the first input stack. Right. Let me just make a little bit more space for myself over here. Okay, that's good. All right, so the first input will be 3, and then 4, and we got minus. That means some subtraction. Right. Pop it off the first time, that'll be the right operand. Pop it off the second time, it'll be the left operand. And the result will just be minus 1, right? And minus 1, push it back to the stack. And then let's go on. The next input will be, after the minus, will be 5. So push 5 onto the stack. And then the next one will be multiply. That means we want to do multiply. And the right operand will be the first pop, which will be 5. The left operand will be the second pop, which will be minus 1. So that means you get minus 5. And make sure you push back to the stack. And that's the final answer you will get. Right? You can again try to verify this result against the infix counterpart over here. Right? So these are the two normal cases. You can definitely get the intuition about how the postfix calculator should really work. but you also need to handle about invalid input. Let's see two examples over here. So input number 3 will be this, right? Let's now try to create a stack for that. Let me put it here. How about that? Okay, input number 3 over here. So 5, 2, 3. 5, 2, and 3. And the next input character is a plus. So that means we want to do some addition. And this will be the first pop, right operand. Second pop, left operand. So that will be the result 5. So we want to push back 5 over here. And the next input character will be multiply. That means we want to do some multiplication. The first pop will be the right operand, 5. And the second pop will be 5 here for the left operand. The result will be simply 25. So we're going to push 25 also to the stack. However, we got another remaining operator over here. However, do we have enough operands or do we have at least 2 items on the stack for its left and right operands? The answer is no. So we only got 1 left. So this will be an error, right? So this is the error case where we got insufficient. We got insufficient operands on the stack. Right? Basically, we are using the plus over here. We can get 25 over here as a first pop. However, for the left operand, we simply get stuck. Right? So that's really what's happening over here. Right? So that's the error. Insufficient operands. And you may have noticed that the infix counterpart that we put over here is not really correct. So we are missing really the left operand over here rather than the right operand. So this is a typo, right? Let me fix that right away. Okay. So let me just fix this over here. Right? So that's really the right way to put it, right? Precision is really important, right? We are missing the left operand over here. Let's now go over the final input over here, the final one. Okay, the final one, let me use maybe orange over here. The final one. And let's use a stack. Okay, let's use the red stack over here. The final case. So we got 5, 4, plus 6. 5, 4, and now we got a plus over here, right? So that means we're gonna have an addition here. Right operand and also left operand over here. And we got 20. Push it to the stack. And now we got 6, right? That means 6 should be pushed to the stack. And that's it. Now we are reaching the end of the input string over here, but we got more than 1 element in the stack, which is wrong. Because whenever you evaluate any infix or postfix notation, the result should be only a single integer. So this expression over here is also not very not valid. So we basically got 5 plus 4, which is 20, and also we got the 6 over here. So this corresponds to these 2 numbers over here. But we have no operator in between to really connect them to evaluate another result. So that's a problem, right? So here we got insufficient operator. Insufficient operator. So you can really use such explanation to really improve the error reporting for your algorithm. I'll let you do the implementation yourself. Right? Insufficient operator. We got 2 error cases, right? Either you got insufficient operator or you got insufficient operands, right? Alrighty. So that's about the postfix notation application I would like to talk about. It's definitely more challenging than the earlier 2 examples, but it's not too bad. So I would say after the illustration I did, hopefully that really helped you get started with implementing and testing this particular algorithm in Java.